Hello again, and welcome to our next chapter in introducing the Anritsu vector signal analysis software. Today we're going to talk about our playback mode. So first I need to load a data set that I think is interesting. This particular data set, it's very large. It's 3 seconds at a 40 megahertz bandwidth. It's 152 million samples. This is data of, I'll just start it playing. Or a radar gun, so the sort of thing you'd measure the speed of a baseball or a moving car, and this turns on. It turns out the way this radar gun works is the signal comes on for about a second and then shuts off for about 50 milliseconds and then turns back on. So it's on several times in the 3 seconds that we have. Those of you that are familiar with Playback IQ data, a file this size, you could at normal playback speeds. You could spend an hour just watching this, looking for something interesting to happen. And so we have some ways to sort of make that a little bit less painful. So a few of the controls, I can pause if I click in either of these areas, sort of play and pause. I have a play button and pause, and I can start over, which is kind of painful because nothing interesting happened, and I can fast forward and rewind. But I also have the ability, if you remember when we looked at our view menu, it was possible to search through the data and look for points of interest, places where the modulation or power had abrupt changes. And I've done that already with this data. It takes a couple minutes, a very large data set, to go through and process all that and then try and find those points of interest. Once you do that, it's saved to disk, so the next time you load the file they come up very quickly, and so they're in the view menu, but I can import those here, and when I do that, then I get a list of time markers. So this is my time marker table, and I can quickly look at one of these points. So we'll just pick one here and play the data there. So I told you the signal turns on and off. And so we can see it was off, and then it turned on, and I have this peak. And we can look at the power versus time and see that it did. Now there's something kind of interesting here, and we might want to have a closer look at that. So I'm going to turn the time resolution up a little bit, and I just put my mouse here and roll the mouse wheel, and then I'm going to replay that. Now I have a higher time resolution, and you can see that as the signal turns on, it shifts to a lower frequency, and then it kind of comes back to its center. It shuts off a little bit, so there's some interesting structure going on as this signal turns on. This signal, like I said, it turns on and off, so I can come here and see where it's off or when it shuts off, and there's also kind of some interesting structure there. That's maybe turn that down, the time resolution, see that a little bit fuller view. When it shuts off, it likes to drift down and then up in frequency as the power slowly goes away. We can jump ahead to the next time this thing turns off and see how consistent it is. And see, this is very easy locating these points of interest. I can quickly jump between these. I can adjust the resolution that I want to look at that with. I can see the next time that's when it shut off. We can look at the next time it turns on. And that looks very much like before, so it seems very consistent, the signal. When it turns on, the frequency shifts down. As it centers, it seems like there's a little bit of cut off there. So anyway, it's a very easy way to look at the data. There's other things we can do here. We can simply scroll through. So right where you have 150 million points, it's hard to easily locate a point of interest, but you can kind of scroll through and see the general shape of things, and that might be useful, right, for a much smaller data set. We can change so I can change the reference level and the scale, dBm per division. I can adjust so I have this so the persistence just lasts. I can clear it so that then when I start something, I don't have the history and can see how this signal moves. Or I can turn the persistence down so if I turn it all the way down, then when I'm playing this, well, I just see the most recent trace. And as I turn that up, then the persistence is longer for the points, and all the way up is things just stay. And that's I can adjust the playback rate, so I can turn it up, or I can turn it down so it's like a trace per second, which in this case would take a year to watch this whole data set. But there are times when you want to watch something, right? You're looking for something, and you want to go very slow. You can also turn it way up. Now in this case, you can go up to the point where the computer is just going as fast as it can, drawing every data point. And then to get more speed, we start skipping ahead in the data set. So that's why this is yellow and then red, just is to warn you that, hey, if I've turned the speed all the way up, I might be missing something. Markers are set, indicated here by this little, so anytime I click on one of these things and jump to a different spot where I've set a marker, I'll see one of these little triangles. That one didn't play. Right, there it is. So marker is there. And that's basically the playback. I have a lot of fine control on the resolution, both in time and in frequency. Playback speed, I can watch the power versus time. I can jump ahead quickly. I can set markers in time or in frequency up here, and those values are shown, and as I play, why there's power levels that are indicated. So a lot of normal sort of playback things you'd expect, but a pretty powerful tool. And that wraps us up. Thank you.